Good morning, all. Am I audible, man?
Sir, yes, sir.
Yesterday we were discussing regarding that work for energy, no? Am I right? Yesterday we have discussed three aspects. We have seen a force F equals 2I minus 3J plus 4K.
Yes, sir, this will
It is pardon? Because you have taken the displacement to the point B. Okay, and you found the work. The second one, what you have done is 3. What is the
3x
second one?
square I cap plus 2y j cap. For, uh, for displacement R1 equal to 2y plus 3j. Ri is equal to 2y plus 3j to 4i plus 6j. R2 equal to 4i plus 6. Then one more. F is equal to yi cap plus xj cap. From a equal to 0, 0, to 1, 1, 1. Yes,
Now you can see this is all these things. What are the common things you have done? Work done is path independent. Now you can see that if, what are the conditions? Agreed. So here,
It depends only on final and initial points.
the given force is a constant force.
Yes.
Okay, the given force the given force is of the type, see, this force is there, no? You are having something of x, some function, okay, and this is a function of y. So for example, this is 3x square I cap plus 2y j cap. Agreed. So this is, do you agree with this or not?
Agree, sir.
Or what is the other one?
Given force is of the type
The
F.
dot product f dot dr,
Yes.
a perfect differential, that is perfect differential means as in 3 what you have,
Y dx plus x dy.
is nothing but y dx plus x dy. That is nothing but d of x comma. It's a perfect differential now.
Yes, sir. Perfect
This is
difference.
what is it called? Perfect differential. Okay,
Yes, sir.
clear?
Clear, sir.
So remember that work done is path dependent only under these cases. Understood this? No, no. The
Yes, sir.
conditions when the work done will be path independent. Follow this?
Yes, sir.
It becomes perfect differential means it gets differentiated in one single derivative.
Yes, P of hopeless fellow. Calculus is going and don't know what is a perfect differential. Huh? Dx is a perfect differential. Dy is a perfect integral of dy is a perfect differential. Okay. D of p, dp integral. You should get p here. Perfect differential means once it is integrated, you should get that function. Learn concepts, man, not the formulas. Because you want advanced exam, you need not formulas. See, tomorrow circular motion only. I posted no syllabus.
Yes, sir. Posted.
Yes, sir.
Complete this.
So that is 2 comma 3 comma 4, sir, from A.
Eh, yesterday we done now. What is that?
2 comma 3 comma 4, sir.
Which one?
In the
Two, three,
first one, sir.
four.
Yes, sir.
Shall I turn this?
1 minute.
Yes.
Completed.
Completed, sir.
Right. In any other case, path should be mentioned. If, for example, a particle is moved, see just like path equation, no? So this is only first one is along y, that means a straight line path, no? Second one is y equals x square. It's a parabolic path. That
Yes.
means I am taking this from 0, 0 to some point 1, comma 1 from 0, 0. This is path 1. Okay, the other path I am taking is via a parabolic path. Understood this? So the
Yes.
point over here is this is the path 2. So the equation of this path is a parabola, no?
Parabola.
Y equals x square and this is y equals x. Till here any doubt is there?
No doubt, sir.
Right. So now you can see that what is the work done along path 1.
Forcing displacement.
Okay. What is the force here? Variable force
D,
xy, comma,
dx, dx, j cap, dy, j cap, dz, j cap.
so now this is nothing but y equals x now. So this is x square dx. So the initially it is 0 and finally it is 1. It comes to 1 by 3 joule. Do you agree with this? Now let us see the work done. We'll compute the work done along path 2.
Integral x cube dx.
How much you are getting?
Um,
1 by 4, no?
yes, sir, 1 by 4.
Why you are getting like this? This path is different, work is changing, no? Why? Because this is not filling any of these parameters. The given force is not a constant force. First one is wrong. The second one is, see, this is not a function of x. You have I cap means it should be a purely a function of x, but here it is a function of xy. Agreed or not?
Agreed, sir.
The
Yes, sir.
third one you can see, it should be a perfect differential. It is not becoming a perfect differential. Is it a perfect differential?
No. No.
So that is the reason why it depends upon path. So condition for a 4 to be path independent. First one, it should be a constant force, or it should be a function of x I cap plus function of y j cap plus function of z k cap, or it should be f dot dr should be a perfect differential. Only under these conditions the work done will be path independent. In all other cases it will be path dependent. Understood the story? Hello?
Understood, sir.
Will you go ahead?
Sir, 1 minute, please.
Shall I return this?
Yes, sir.
Wait, sir. 1 minute.
1 minute, sir.
Complete.
1 minute, sir. Yes, sir. Complete, sir.
Right. See, for example, we are having a situation like this. It's a block. It is pulled up. The block is pulled up. Okay, so now this has okay, now if you don't know Newton's laws and friction, you cannot solve this. That is the problem. Understood this?
Yes.
When it is moving up,
So one
friction
doubt.
will be acting in which direction?
Sir, one doubt. This MG
Okay.
same theta, no, sir.
Okay.
This MG can be cos theta.
Yes, yes, correct. Okay. Now after this, right. Now calculate the work done by each. See, the displacement is x. Then what is the work done by normal reaction, man?
Zero because no displacement. Charge.
Work done by mg cos alpha cos theta
MG cos theta x
into
into
x into cos 90.
0.
What is the work done by f sin alpha?
Same. X sin alpha into x cos 90 degree. 0.
Like this, we can calculate even for mg sin theta is
This sin theta into x into
cos 180 now.
minus into sin theta equals.
Work done force of friction
Same also.
Fk into x into cos 180.
Minus fk. Mu k and x.
N is nothing but mg.
Mg.
Agreed.
Yes, yes, yes.
Any doubt?
Sir, sir, n is equal to sin alpha minus mg cos theta.
N is this one, no? Correct, no? Here.
Yes, sir, sir. So, sir, my mistake.
So one. How many forces are there? 1, 2, 3, 4, 5, 6. Follow this, how to calculate work in different situations.
Yes, sir. Also.
Okay, now this is for doing this, you need to know
Friends.
Newton's laws, friction, it's all interconnected. Now again after work for energy, again we will come back to circular motion because we need the concepts of energy to solve circular motion problems. So like that is all intertwined and interlinked. In isolation you cannot study. Shall I turn the page? Hello?
Yes, sir.
Complete this?
1 minute, sir.
minutes.
Your exam is in the afternoon, you know?
Yes, sir.
Yes, sir.
Tomorrow morning I'll take the class from 11 to 1 because seniors are. You have any KVP exam tomorrow?
Yes, sir. Tomorrow it is there,
Yes,
sir.
sir.
Oh, you two are writing. Okay, so then no need.
Yes, sir.
Right, go ahead.
You boys
Till
only
it,
are writing, sir.
pardon?
You are only writing, sir. Not all are writing.
Already they'll miss the class, no? Officially we cannot conduct, no? Right, take another problem. Complete this.
Yes,
Yes,
sir.
sir.
Completed.
Hello?
Completed, sir.
It's a bucket. It is lifted by a rope. And it is bucket is lowered like this. Melissa, one
అమ్మ వెళ్తుంది నేను వస్తా. గిన్నెలు ఇల్లు ఊడ్చుకొస్తా.
గిన్నెతో
ఇల్లు ఊడ్చుకోవట్టు గిన్నెలు నీళ్ళు ఇలా అంతా ఎండిపోయిన నీళ్ళు లేరా లేవలేదా తోపు వాళ్ళు
Shall I do it?
1 means, sir.
Work done by string means what we need.
And work done by tension.
Tension you have to calculate. This is T, this is mg. What is the governing equation?
E is equal to mg plus mg means mg by 3 mg by
So T is upward, displacement is downward, cos 180. 3 mgl by 4. Is it clear? Shall I turn this?
is
Hello?
1 minute, sir.
Completed?
1 minute, sir.
completed.
1 minute, sir. Complete, sir.
Take another call. it visible?
Sir, little.
One second.
Sir, right.
Now,
Now it is okay, sir. Okay, sir.
Visible, sir.
clear now?
Yes,
Sir.
Completed, man?
Yes,
Hello.
sir. Completed.
Any answer?
Sir, doing, sir.
Do you agree with this?
Agree, sir.
So this is the friction. Displacement is given as 2 meters. So we can find out what is the UK is given now 1/4.
Yes, sir. 1/4.
Okay. So now you can find what is asking. Find the work done by force F. Force F is easy on that.
F plus cos 45 degree.
This is nothing but f into 2 into cos 45. This is
F
root 2.
plus
Then what else is asking? Friction. Fk into s into cos of the angle between them. Okay.
yes, sir. 1 by 4 into g minus degree into minus 1. Sorry, 2 into minus 1.
Work done by gravity is how much?
0 mg into s into cos 90.
Understood this? Clear?
Clear.
Completed?
Completed, sir.
Yes, sir. Complete.
Take another problem.
Completed.
Note on that.
Yes, sir.
How much of them? సరే సరే అది యూనిట్ కలర్ కూడా బ్రిలియంట్ ఒకటి గోల్డ్ గోల్డ్ కలర్ గోల్డెన్ కలర్ ఒకటి ఇంకోటి బ్లూ ఉంటుంది కదా సర్లే నాకు గుర్తుంది వెనకాల స్ట్రిప్ మీద బ్లూ కలర్ ఉంటుంది ఓకే ఎడిటర్ ఇది నైట్ అంతే కదా రైట్ ఓకే సరే ఓకే రైట్ ఎడిటర్ ఉందా ఓకే 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 రైట్ అది నైట్ అంతే కదా రైట్ ఓకే రైట్ రైట్ చేరిపోయావా completed?
Sir, 1 minute, sir. Completed, sir.
Right.
2 minutes, sir.
Return this.
Done, sir.
See, here also if you read that question carefully, there's an elevator. In that elevator is a block. V is constant, he said. That means the acceleration is how much?
dV by dt is equal to 0.
Agreed?
It's a constant velocity.
Now you can see what is the mass of the block.
1 kg. 1 kg.
This is the friction now. Incline is what?
Inertia.
No acceleration, no? He says. They
No
agree with this? No?
Yes, sir.
Therefore, F should be balanced by what?
mg sin 45 degree.
Agreed. So now what he says is, in 1 second, what is the distance moved by displacement of elevator in 1 second? Can you tell? It is ut. There is no acceleration, no?
0.
Two.
Yes.
What is that? V is given. How much V?
2
2.
2 meters per
1. This is half. There is no acceleration. So this is 2. Now you can see displacement is in which direction? Upward. Because this is the friction. What is the angle between them? Can you tell? This is 45. This is also 45 now. That means you have this is the displacement. This is 45 degrees. Agreed?
Degree, sir, degree.
Work done by friction is asking. Fs cos 45. Okay. Friction is nothing but
mg sin 45 degree.
2 cos 45. So this is sin 45, 2 sin, what is that it equal to?
Yeah,
2 into 45, 2 theta no? mg
Yes, sir.
sin 90 no? 1 mg. What is mass of the block? 1 kg. G is 10. That means 10 joules. Understood here? Is it clear?
Yes, clear. Sir.
Finished this?
Yes, sir.
Yes, sir. 1 minute, sir.
completed.
Is it visible?
Yes,
Can you move
sir.
it to right, sir?
Hmm?
Can you move the tablet to right? Thank you, sir.
I'll read if you want. Two equal masses are attached to the two ends of a spring.
Yes,
of force constant K. Visible?
visible, sir.
Yes, sir. Yes, sir.
The masses are pulled out symmetrically. This the word is symmetrically to stretch the spring by 2x naught over its natural length. Find the work done by spring on each mass.
Sir, what is that? Stretch the length by?
2x naught by a length
Okay.
2x naught over its natural length. Over its nature, that means stretching is 2x naught. Understood this?
Yes, sir.
Yes, sir.
Extension.
Shall I turn this?
Yes,
1 minute.
sir.
Done, sir.
See, you know that work done by spring force is how much?
Um, half into K into x square minus xi square.
Finally 2x naught, no? Initially no extension, no?
Yes, sir. No extension. 2 4 square K.
Forward this.
Yes, sir.
Yes, sir.
4 square into K.
Understood this?
Sir, K
Sir,
is
it will be minus 2x naught square k, no, sir.
Pardon?
into.
Minus 2x naught square k.
K is there. Okay.
Yes, sir.
Yes, sir.
Now, however, this is work done is the total work done by spring. But that fellow is not asking you this. That fellow says that there are two masses. Okay.
Yes, sir.
Each. So now you can see the spring is stretched by 2x naught, is saying. Symmetrically. Symmetrically means each block is displaced by the same amount. So the total stretch is x naught. This is L naught. Okay, now the string will be extending by how much?
L naught plus 2x naught.
Okay, so this is not the answer. Be careful with that. Okay, so here this is a spring force. Okay, what is the spring force?
And force minus Kx.
Okay, anyhow, magnitude wise, this is it. Work done by spring force.
Kx naught into x naught cos 180.
This is spring force.
Yes, sir.
Okay, this is the displacement now
Yes, sir.
is spring force into x naught
Cos 180.
cos. Can I write like this? So this is also wrong. You have to use variable force now.
Yes, sir. Yes, sir. Yes, sir.
Is that
Okay.
2x naught, sir?
It's a variable force. Variable.
Okay. Am I right?
Yes,
Is it correct?
correct, sir. Correct.
Do it.
Yes, sir. 1.
Sir, minus kx dx into minus 1, no, sir.
Then this magnitude we should take, no? Mod f
Yes, yes.
mod dr cos theta, no? This is what we take. No? So,
Yes, sir.
dot product we take mod solo, no?
Yes,
Yes,
sir.
sir. We take that.
Understood this?
Understood, sir.
See, remember, hello, this
Yes, sir.
is also wrong only. Why? Because what is the spring force you have?
Uh, Total spring force.
Total extension. It is total extension, not extension on one side. Followed this?
Sir, that point I didn't understand, sir.
Uh,
Sir, because
force, spring force is what, man? Total extension, no? What is the total extension?
2x naught.
Minus x naught square.
Extension of spring is how much?
2x not.
X naught plus X naught.
Yes, sir.
So what is the spring force you have?
Total
K
spring.
into 2X naught, no?
Yes, sir. Sir,
Agreed.
but this in case of one block, no, sir. That is
But
my doubt.
what? No, no, this is defined only for the entire spring, no?
Oh, okay,
So, for
sir.
example, somebody slaps you, the pain is for the whole body, no?
Yes, sir. What would-
That means it is an equally distributed throughout. The pain in one sub part of our bodies is perceived by the brain equally, no?
Yes, sir.
So,
Equally.
like that is a total one. You cannot divide the force. That is the reason why I gave this problem. Understood this?
Okay.
Clear? Therefore, now why I have done this? Usually people do this wrong actually. So here this work done is shared. Work done I block 1 is nothing but half of this. How much is that?
X not square K.
On each block. Understood this?
Yes,
Clear or
sir.
not?
Clear, clear.
So don't do this. This is actually wrong. Understood this?
Yes, sir.
Calculate the total work and that is distribute equally. Divide that. That's it. Understood this?
Understood, sir.
Now 11 o'clock you have math class, no?
Yes, sir.
Yes, sir. 11 o'clock.
Any doubts are that till here?
No doubt,
No,
sir.
sir.
Sir,
Only one.
now we have to.
Pardon? Some doubt. Hello?
Sir,
Tell.
sir, now f spring is equals to minus k into 2x naught. Again, we have to now integrate. Now this.
If you integrate, you'll get the same thing. Now you have to take
Not
this.
sir, k.
You'll get the same thing. Same thing will come. Okay? That's why this method is better. Okay? Clear?
Yes,
Yes,
sir,
sir.
clear.
Sir, but he asked on each master, sir, for
That's why here I wrote here. You cannot find work done by a spring on left side, right side. That is not possible. Work done by a whole spring. For example, you moved from one place to another place. work done by you will, so we cannot say work done by your finger, work done by a head. Is it possible?
No, sir.
So work done by each end of the spring is not defined. Work done by entire spring is there. Understood this or not?
Understood, sir.
Understood.
Clear?
Yes.
Okay, go to your math class. Evening, I'll try to take a class. Okay?
Yes.
Right.
Yes, sir.
Right. Bye.
Okay, sir.
Sir, evening which time, sir?
After 7 only, not before that. 7:30 11. Hello?
Okay, sir.
Yes,
If
sir.
not today, tomorrow evening I'll take. Someday. Because we missed one class, now I'll compensate that. Okay.
Okay, sir.
Thank you, sir. Bye.
Tomorrow morning or early morning is okay now for you people?
Yes, sir.
Okay, sir. Yes, sir. Yes, sir.
7 o'clock like that, that is awesome. For you?
Yes, sir.
Jasim?
Okay.
Yes, sir. For
Yes,
me,
sir.
it is also, sir. No problem.
Okay, right. Okay.